Hello, welcome to this video. This is 6-1. We are talking the second fundamental theorem of calculus, and the second video will focus on interpretation of rate graphs. Okay, so let's go ahead and get right to it. Start off by remembering that when we integrate a function and then take the derivative of that, what we really get, the answer is just the integrand. So here we have some examples that kind of follow that idea, and we're going to help develop the second fundamental theorem of calculus. Okay, so number one, here we want to integrate integrate 0 to x 2t minus 3 dt. So when we integrate this, we get 2t squared divided by 2 minus 3t evaluated from x to 0. Now, if we go ahead and evaluate this, what we end up getting, right, these 2's cancel, and we get x squared minus 3, 3x, okay, minus, now I'm going to plug in 0 here, and 0 squared is 0, minus 3 times 0 is 0. So our answer would just be x squared minus 3x. Okay? Now what we want to go ahead and do is we want to take the derivative of that same integral. Now, when we take the derivative of that integral, okay, what we're doing is we're taking the derivative of this. Well, the derivative of this answer here is 2x minus 3. Okay. All right. It says, do you notice anything yet? Do you notice anything? Okay. Let's go ahead and look at another example. Here I have the integral from 10 to x of f prime of t dt. Well, if I integrate f prime of t, a function, this is just f of t, okay, again, evaluated from 10 to x. Okay, so that would be f of x minus f of 10, which is a numerical value, right? And this is a constant, this value. Okay. All right, let's go ahead and look at number 4. And on number 4, we're taking the derivative, again, of number 3. So it's the integrand and the integral is exactly the same for number 3, and we're just taking the derivative of that. Well, if I want to go ahead and take the derivative of this, okay, so the derivative is going to be f prime of x, okay, this one moves over, okay, times the derivative of the inside, right? And the derivative of x is just 1. I'm going to include that. You'll see why I'm doing that later, maybe. And then I'm going to take the derivative of constant, which is just 0. Okay? So here is the second fundamental theorem of calculus. So it says for any constant a, where we're taking the derivative from a to x of f of t, is equal to f of x. Okay, so when you start out with a constant, this is important, when you start out with a constant and you integrate to x, your integral is just going to be f of x. Okay, so the derivative of the integral is just going to be f of x. All right? Okay, so fair enough. Well, now let's go ahead and look at another kind of version of the second fundamental theorem of calculus. Here I have the integral from 0 to x squared of f prime dt. Well, again, I'm going to integrate f prime of t, so this just gives me f of t, and again, we're evaluating from x squared to 0. So this is f of x squared minus f of 0. Okay, all right. Number 6, they want us to now take the derivative of this, okay? And this is helping you develop the second fundamental theorem of calculus. And notice, I'm going to take the derivative of my function, okay? So the derivative of f of x squared is f prime of x squared. But notice I have a function on the inside, so we have to utilize the chain rule, okay? And then I'm going to take the derivative of f of 0. Well, that's a constant, so we're done. All right, number 7, same type of idea here. Okay, so I have the integral of f prime of t from x cubed to 2x. So when I integrate, this just becomes f of t evaluated from x cubed to 2x. So this would be f of 2x minus f of x cubed. Okay, so I'm not doing anything special or anything weird with these problems. We're just helping you develop the second fundamental theorem of calculus. And notice now we're going to take the derivative of problem number 7. Okay, so that's what 8 is. So I look at this, I want to take the derivative. Well, the derivative, and I'll just put it here so maybe you can see both. So the derivative is going to be f prime of 2x, but then I also have the derivative of the inside. So multiply by 2, and then I'm going to subtract the derivative of f of x cubed, so that's f prime of x cubed, okay, times the derivative of the inside, which is 3x squared. Okay, and hopefully you noticed some changes. In these examples up here when we were developing the second fundamental theorem of calculus, we were just taking the derivative of the integral of a function is that function, okay, of x from a constant to a variable. And then down here, now we're doing that, but we also have to add on our hook or our chain. Okay, so this is the chain rule version of the second fundamental theorem of calculus. It says if u and v are functions of x, then the derivative of the integral from u to v of f of t dt is f of v times v prime minus f of u prime. And kind of how I remember this and what sticks out to me is I almost envision these as inverses or opposites, that they cancel each other out. So when you take a derivative of an integral, you're left with the inside, but with definite integrals, we have bounds from v to u. So I have to go ahead, I have to evaluate at those bounds, and then we subtract. Well, if u and v are functions, okay, meaning that they have derivatives themselves, we have to use our chain and multiply by those values. Okay, so let's go ahead and look at some examples here. And number 9, this one's a little bit different. The first thing that I'm going to go ahead and do is rearrange these bounds, because notice from the second fundamental theorem of calculus that your bound, the first bound, your lower bound, is a constant. So I want to rearrange this. So d dx of the integral from 0 to x of 2t minus 3 dt. Now, when you do this, you can't just flip your bounds, and when you, well, you can, but you have to go ahead and again adjust this. You have to multiply by a negative. Okay, so I'm gonna incorporate a negative, and actually properly it should be right here. So negative, and I'll add d dx. Okay, I'm taking the derivative of this integral. Okay, so let's go ahead. Notice now I'm integrating, I'm taking the derivative of the integral from a constant to a variable. So what does the second fundamental theorem of calculus says? Well, it says that it is just going to be the integrand evaluated at that value. So negative 2x minus 3. Okay, and if we go ahead and simplify this, this is negative 2x plus 3. Okay, and there's your answer. Pretty simple. All right, the next example, notice here I'm taking the derivative of an integral from a constant to a constant. Okay, well, when I'm taking the derivative of integral from a constant to a constant, these are constant functions, right? They're constants, and when you take a derivative of a constant, what's the answer? 0. So 0 minus 0 is what? 0. That one's super simple. All right, number 11. Okay, and here's where you'll start to see the fundamental theorem of calculus, and this is the chain rule version of the second fundamental theorem of calculus. So I'm going to go ahead. I'm taking the derivative of an integral. Okay, again, remember these are inverses, so stuff's going to cancel. We're just going to be left with t squared plus 2t dt. Okay, and again, we have to evaluate at our bounds. So we have x cubed quantity squared plus 2 times x cubed. Okay. Actually, yeah, no, that's right. X cubed. Okay, and I have to go ahead and multiply now by the derivative of the inside. I'm taking the derivative of this. So this is going to be times 3x squared. Okay, and if I just clean this up a little bit, we have x to the 6th power plus 2x cubed all times our derivative of the inside, 3x squared. And there's your answer. All right. Okay, let's make this a little bit more complicated. Let's look at two functions, from a function to a function. So this is, if I go back to our notes down here, here's the example of a chain rule where we're looking at u and v are both functions. So we're going to have derivatives for both bounds. So again, I'm taking the integral from 2x to 3x, and then I'm going to take the derivative of that. Well, second fundamental theorem of calculus says that it's just going to be the integrand evaluated at these bounds. So I have 3x quantity squared plus 2 times 3x times the derivative of the inside, which is 3. Okay, and I'm going to now subtract. And I'll use this in a different color. So say this is 2x here. I'm going to subtract 2x quantity squared plus 2 times 2x times the derivative of the inside, which is 2. Okay, and that's good enough to be your answer. So you could simplify a lot there, but there's your answer. All right, and then one more, we'll just look at if our bounds are just general functions. So again, I'm taking the derivative of an integral. Hey, they kind of cancel out, and now we're just going to evaluate at these bounds. So we have 2 times g of x minus 3. And then notice g of x a function, so I have to go ahead and multiply by the derivative of the inside. So that's g prime of x. Okay. And I want to subtract this. Okay, and I want to subtract my integrand evaluated at the lower bound. So 2 times f of x minus 3 times the derivative of the inside, which is g prime, not g prime. Come on, Schwarber, f prime of x. Okay. And there you go. That's your answer. All right, number 14, they're getting weird. This one is as simple as the previous ones. They're just wording it differently. They're saying if this integral from 0 to 3x squared of 1 minus t squared to the power of 10 dt is f of x, then what's f prime of x? So they're asking you, again, to take the derivative of this function. So we'll go ahead and do that. We'll, again, use the second fundamental theorem of calculus. Notice your lower bound's a constant, so that derivative is going to be 0, and I can evaluate this function. So this is 1 minus t squared, okay, and again, t in this case is 3x squared, and all of this is to the power of 10, and we're going to multiply by the derivative of our bound, which is 6x, okay? And minus, again, our lower bound, which is 0, okay? But I'll clean this up. So this is 1 minus 9x to the 4th to the power of 10 times 6x. And there's your answer. All right, in this video, we helped develop the second fundamental theorem of calculus, and then we looked at some examples with the second fundamental theorem of calculus. All right, watch the next video. We are going to talk about rates in that video. Catch you next time. Peace.